So we have exhausted or looked at this sum and the difference rule. We look at techniques for integrating large variety of functions involving products, quotients, and composition. So to be able to do this, we look at one use of antiderivatives, and that is to solve differential equations. I'm going to be using DE throughout. DE means differential equation. So a differential equation is an equation that relates an unknown function and one or more of its derivative. An example is if I have f prime of x plus f prime prime of x is equal to maybe some number m, then this is known as a differential equation. And a simple example of a differential equation is if I have dy over dx is equal to f of x. Now solving this equation means finding a function y, all right, with respect to, with derivative f. Therefore, the solution to this simple differential equation are the antiderivatives of f. Remember, antiderivative of f is a function f of capital F whose derivative is equal to f of x. So if I have dy dx, then it means that y prime of x is equal to f of x. And this is the exact definition of antiderivative of f of x. All right. So therefore, the solution to this simple differential equation are the antiderivatives of f of x. So if capital F, all right, is an antiderivative of f, every function of the form capital F of x plus c, all right, is a solution to this differential equation. All right, so let's look at an example. Given that dy dx is equal to 3x squared, solution is given by the antiderivative of this function. And I remember we said another form of writing antiderivative of f of x, this is the same as integral of that function 3x squared dx. And since we know how to integrate a function now, this is equal to, pull 3 out, integral of x squared dx. Using the power rule, this is 3. We add 1 to the exponent and divide it by the function, 1 over 3x to the power 3 plus c. This is equal to x cubed plus c. Now the problem of finding a function y, okay, that satisfies a differential equation dy dx is equal to f of x with additional condition. Let's say y of x naught is equal to y naught. It's an example of what is known as initial value problem, which we're going to shorten as IVP. The condition y x naught is equal to y naught is known as initial condition. All right, so if we want to find a solution to this simple differential equation with an additional condition, then such a problem is known as initial value problem. And this condition here is known as the initial condition to the system of differential equation. Okay, so let's look at an example that we saw earlier. Dy dx is equal to 3x squared. Let's look for the function y, a solution to this function with the initial condition y of 2 is equal to 5. All right, so first of all, we find the antiderivative of this function. That means we'll have y is equal to the integral of 3x squared dx. This is equal to 3 integral of x squared dx. This is 3 times 1 over 3 x cubed plus c. This is equal to x cubed plus c. But we've been given the condition that y of 2 is equal to 5. That means y of 2, this is equal to, wherever we see x, we put 2 there. So we have 2 cubed plus c, and this whole thing is equal to 5. So this is equal to 8 plus c is equal to 5. Therefore, c is equal to 5 minus 8, which is equal to minus 3. Therefore, y is equal to s cubed minus 3 is a solution to the differential equation dy dx is equal to 3s squared with the initial condition y of 2 is equal to 5. Now let's look at another example of IVP. We want to solve dy dx is equal to 4x to the power minus 3 with the initial condition y of 1 is equal to 3. Alright, so a solution here is to find the antiderivative of 4x to the power minus 3. So we have y is equal to the integral of 4x to the power minus 3 dx. This is equal to 4 integral x to the power minus 3 dx. And this is equal to 4 times, you add 1 to the exponent, that will be minus 2 here. Okay, x to the power minus 2 plus c. And this is equal to minus 2x to the power minus 2 plus c minus 2 over s squared plus c. But we have the initial condition that y of 1 is equal to 3, right? So y of 1, this is equal to minus 2 over 1 squared plus c. This is equal to given 3. Okay, so we have minus 2 plus c is equal to 3. Therefore, c is equal to 5. And so the solution to that simple differential equation is y is equal to minus 2 over s squared plus 5. This is a solution to the differential equation dy dx is equal to 4x to the power minus 3 with the initial condition y of 1 is equal to 5.